All right, for 33 and 34, we're working back with stuff from the second unit with logic. And an inverse for number 33 is when you take and negate the hypothesis and conclusion. So it's going to go in the same order as the original statement. If two lines intersect at right angles, then the lines are perpendicular. We're going to negate or make opposite with the inverse here. So this is going to say if two lines don't intersect at right angles, then the lines are not perpendicular. And I'm just going to use that little symbol there for perpendicular. The contrapositive, it switches the hypothesis and conclusion and negates both. So we're going to take this statement, we're going to flip the hypothesis and conclusion, and we're going to make both of them opposites. So it says if an angle is acute, then its measure is between 0 and 90. If an angle's measure is not between 0 and 90, then it's not acute. (35) To classify a triangle by its side lengths, you've got two lengths that are the same. If that's the case, then that's going to be an isosceles triangle. All right, for 36, we're going to turn this into a conditional statement, so I need if-then. So I'm just going to kind of write it as they have written it here. I'm going to write if an angle is obtuse, then its measure is between 90 and 180. Now, that's true. So if we write the converse, we're going to flip the hypothesis and conclusion. It's going to say if an angle's measure is between 90 and 180, then the angle is obtuse. Both of those statements are true, so if the original conditional statement and its converse are both true, you can turn it into a biconditional. So I'm going to take the original statement up here, and I'm going to say an angle is obtuse. The biconditional has if and only if, which I'm going to abbreviate there. An angle is obtuse if and only if its measure is between 90 and 180. All right, for 37, we are doing the right triangle similarity theorem. So there's three different triangles within this picture, and they're all similar to each other. I'm going to draw the little bitty baby triangle, which is right here, and that has sides 4 and x. The medium-sized triangle is not shaded when I just did that, but I'm going to turn it so it's oriented the same direction. And that one, the short leg would be x, the long leg would be 21. And what I can do here, since I know these two triangles are similar, is set up a proportion. So I'm going to go x over 4 right here equals 21 over x. We're going to cross multiply. This is going to give us x squared, and that's going to be it's going to be 84 here, 4 times 21. Now, we're going to write this in simplest radical form. Actually, the biggest perfect square that divides into 84 is 4. So you can use a factor tree here, or the biggest perfect square that divides into the number, however you want to break it down. What I can take out here in front, 4 has a perfect square root of 2. The 21 is going to have to stay under the square root. So the value of x there is going to be 2 times the square root of 21. For 38, we got similar rectangles here. So the 12 and the 5 are corresponding sides. So let me put those into a fraction. The y plus 3 and the 8 are corresponding sides. Since I put the 12 on the top, I want to put the y plus 3 on the top, so these are the same figure. And then you have corresponding parts within the same fraction. So the 8 is going to go on the bottom. We're going to cross multiply. Make sure you're real careful here to distribute. So you're going to get 5y plus 15, 5 times y and 5 times 3. and if you multiply 12 and 8, you're going to get 96. Now, we're going to subtract 15 from both sides. We're going to get 5y equals 81, and then we're going to divide both sides by 5 there, and if you want to, you can just leave it as that fraction right there. What I would do for number 39 here is the side splitter theorem. We've got parallel lines cut off by multiple transversals. If this whole side is 11, and I know that much of it is 6, I can subtract and get the 5 here. And then what I'm going to do, I'm just going to go straight down the same transversal, 6 over 5, and the 2x plus 4, that's cut off by the same two parallel lines as the 6. X plus 6 here is cut off by the same two parallel lines that cut off the 5, and we're just going to cross multiply. Just don't forget to distribute here. We're going to get 6x plus 36, and then that's going to be 10x plus 20. There's different ways to solve this. I like to try to keep the variable positive if I can. I got 36 equals 4x plus 20. Run out of space here, but if you subtract the 20 there from both sides, you're going to get 16. So our x value in this case is going to end up being 4. And number 40 here, what I would do is I've got an exterior angle here. I know this angle and this angle right here that we don't know have to add up to 180. So if I do 180 minus 106, we're going to get 74. And then what I know from that information is the three inside angles of a triangle do add up to 180. So if we do 180, we're going to subtract the 74, subtract the 61, and the leftover should end up being our x value. And that'll give us 45 degrees.